So in this video, we're going to talk about some important characteristics of polynomials. So remember back in Algebra 1, you talked about the parts of an expression. The number that multiplies a variable is called a coefficient. So in this case, 4 is the coefficient of x squared. The variable is the unknown term in our expression. So in this expression, we have x. The exponent tells you the power of any term. So in this case, we have x raised to the second power. The constant term is whenever you see a number that's by itself, okay? So in this case, 3 would be a constant term. So notice that this expression, 4x squared minus 3, has two terms in it. Also notice that the first term is 4x squared, and the second term is 3. So when we talk about polynomial basics, we're going to get into some definitions, okay? And these definitions are going to help us understand what's going on in this unit. So a monomial is a number variable or the product of a number and one or more variables. So for example, negative 14x is a monomial. We have negative 14 times x. 100 is a monomial also. It's just a number by itself, but that's a monomial. It's very important to notice that the exponents of the variables in a monomial must be non-negative integers, okay? So here you see 36x squared is a monomial, but 36x to the negative 1 is not a monomial, okay? Because that is a negative integer in the exponent. Similarly, 100 is a monomial, but 100 over y squared is not a monomial, because if I were to write this, this would be 100 times y to the negative 2, okay? And we can't have those negative exponents in our monomial terms. Also notice here that we can have more than one variable in our monomial, right? We have negative 45x cubed y to the 5th z, which is a monomial, but 5x to the 1/2 is not a monomial because that 1/2 is a fraction exponent. So we also will talk about polynomials. So a polynomial is a monomial, okay? So all of these monomials are polynomials, or it's the sum or difference of two or more monomials, okay? So that's why in this case, this was not a monomial, x plus 2y, but it is a polynomial. So binomials are polynomials that have two terms in them, okay? And trinomials are polynomials that have three terms. And you can identify the terms because they'll be separated by addition or subtraction signs, okay? So you can see here we have examples of binomials. Everything with three terms is a trinomial. And then if we have multiple terms, we have polynomials. So notice that 9x squared plus 3x minus the square root of x plus 1 is not a polynomial, okay? Why? Because that square root of x, well, that we can rewrite that as minus x to the 1/2, okay? So if it has a term in it that's not a monomial, then that means that it's not a polynomial, okay? Because a polynomial is a combination of monomials. So now you can go ahead and pause the video and try doing this example on your own. So in this example, it wants us to think about whether these expressions are polynomials. So notice the first expression is a polynomial because all of these are monomial terms, right? And they're just added together. The second expression is not a polynomial because this last term right here, this 5 over x, can be written as 5x to the negative 1, and it's not a monomial. If we have C, it's not a polynomial because notice that this 3 square root of x is not a monomial term, right? The square root of x is x to the 1/2, so that makes it not a monomial. And then 56, which is just a constant, is also a polynomial because 56 is a monomial. Okay, so we can also talk about the degree of monomials. The degree of a monomial is the sum of the exponents of its variables. So if a monomial has just one variable in it, it's just going to be equal to that exponent. So the degree of 3x squared is just going to be 2. Okay, so if we have more than one variable, we're going to take those exponents and we're going to add them together. So the degree of 4x cubed y to the 4th is going to be 3 plus 4, which is equal to 7. Well, what if we have a constant term? So one way to think about a constant term is like there's an x to the 0 with it. Okay, remember that x to the 0 equals 1. So that's why the degree of a constant term will just be 0. Okay. So if we have the monomial x, y squared, z cubed, well, when we add them together, remember that x has an implied exponent of 1, okay? And if you want, you can go ahead and add those exponents of 1 back in if it helps you keep track of things. So we're going to add together all three exponents. So we have 1 plus 2 plus 3, which is equal to 6. So the degree of a polynomial will be equal to the highest degree of its monomial terms. So when you're figuring out the degree of a polynomial, you'll just kind of go ahead and identify the degree of each monomial and then pick the highest one. So this first polynomial here, you can see this first term has a degree 2, the second term has a degree 1, and then the third term has a degree 0. Okay, so the overall degree of the polynomial is going to be 2 because that's the highest degree. The second polynomial, 4x squared y to the fifth minus 6x cubed, well, this first monomial is going to have a degree of 2 plus 5, which is 7. And the second term has a degree 3, so the overall degree is going to be 7. Okay, so you just pick the highest one. Let's look at this last polynomial. So we have 2 plus 3, so first term has a degree 5. Second term has a degree 13, right? 4 plus 9. Third term has a degree 7, and the last term has a degree of 1. Okay, so the overall degree is going to be 13. So it's going to be very important that we write some of our polynomials in standard form. So our polynomial will be in standard form when the terms are written in order from highest degree to lowest degree. Okay, so notice that this polynomial right here is in standard form because I have this fifth degree term, fourth degree term, third degree, 2, and then remember this is a first degree term and this is a 0 degree. Okay, so my terms go in order 5, 4, 3, 2, 1, 0. So the degree of a polynomial in standard form can be easily identified because you just have to look at the first term, right? So we don't have to kind of dig through and figure out all the degrees. We can just say this is a fifth degree polynomial. So the first term, when a polynomial is written in standard form, will be known as the leading term. Okay, so in this polynomial, the leading term is 3x to the fifth, and then that leading term, the coefficient of it, will be known as the leading coefficient. Okay, the leading coefficient of this polynomial is 3. So we can also classify polynomials by its degree. Okay, so before we were talking about polynomials in terms of how many terms they had. So we had like binomials, trinomials, and polynomials for anything beyond that. So by classifying by its degree, we're saying that if it has an overall degree 0, then it's going to be a constant. Okay, so like 7 is a constant. If it has an overall degree 1, then it's a linear. Okay, so we have 2x minus 5, which is linear. If it has an overall degree of 2, then it's quadratic, so like 3x squared plus 2x minus 4. Overall degree is 3, then it's cubic, like 4x cubed minus 6x squared plus 3x plus 2. Overall degree is 4 is quartic, so if we have 5x to the fourth minus 2x cubed plus x minus 1. Obviously, this list can go on forever, but I just kind of listed out the common ones that we'll see in this class. So let's practice by rewriting this polynomial in standard form and then classify the polynomial by its degree and number of terms. Okay, so to rewrite in standard form, I'm going to go through and figure out the degree of each term individually. So 3 has a degree 0, 5x cubed has a degree 3, minus 7x squared has a degree 2. So when I rewrite in standard form, I'm going to write the highest degree first. So I have 5x cubed, and then next I have minus 7x squared. And this 3, well, that's going to be a plus 3, okay? Remember when I was rewriting, I kept the sign that was in the original polynomial in front of the term with it. But then this 3, you may be wondering where I got the plus from. Well, the reason is because that 3 is a positive 3, right? So it's kind of like it has a positive sign there. We just haven't written it. So that's why when I rewrite it in standard form, I can just go ahead and add in that plus. Okay, so this will have degree 3, right? Because that's the highest degree. And it has 3 terms, right? So since it has 3 terms, it's going to be a trinomial. And since the degree is 3, we would call this a cubic trinomial. So now let's rewrite this polynomial in standard form and then classify it by its degree and number of terms. Okay, so let's identify the degree of each term. So 14 has degree 0, minus y squared has degree 2, minus 6y cubed has degree 3, 9y has degree 1, minus 7y to the fourth has degree 4. So the highest degree term is going to be minus 7y to the fourth, and then I have minus 6y cubed, and then I have minus y squared, and then plus 9y, and then plus 14. Okay, so notice the overall degree is going to be 4, And let's count up how many terms we have. So we have 1, 2, 3, 4, 5. Okay, more than 3 terms is just called a polynomial because poly means many. So we just have many terms. And the degree is 4, so it's going to be quartic. Okay, so this is a quartic polynomial. So now you can go ahead and pause the video and try doing this example on your own. Polynomial, we have negative 4x cubed plus x squared minus 9x plus 16. The highest degree term is a degree of 3, so this has degree 3. It has more than 3 terms, so we just call it a polynomial. And since it's degree 3, it's cubic. So this is a cubic polynomial. So remember that a polynomial is an expression containing a monomial or monomials combined with addition or subtraction. So a polynomial is in standard form if the monomial terms are written in order from highest degree to lowest degree.